Welcome back. Today, we dive deep into the engine room of modern AI applications, vector stores. Our main focus will be integrating and mastering ChromaDB and FAISS. Let's start with the what. Vector stores are specialized databases explicitly designed to store, manage, and query high-dimensional vectors. Why do we need them? Traditional databases are great at structured data, but they search for exact keyword matches. When we deal with large language models, we need to search by meaning. By converting text into dense numerical representations called embeddings, vector stores allow us to perform semantic searches. This means a query for feline will match documents containing cat or lion, even if the exact word is missing. How does this work? The database calculates mathematical distances, such as cosine similarity, to find the closest vectors in the space. This forms the absolute foundation of the retrieval augmented generation, or RAG, architecture. Looking at this flowchart, you can see the fundamental lifecycle of a semantic search. The user query comes in on the left and is immediately processed by an embedding model to generate a vector. This vector is then pushed into the vector store in the center. Inside the store, the system calculates distance metrics, like cosine similarity, against all stored document vectors. Finally, it outputs semantic results, the text chunks that are most closely aligned with the true meaning of the user's query. It is a highly efficient, meaning-based pipeline. Moving to our first deep dive, ChromaDB. What is it? ChromaDB is an open-source vector database tailored specifically for AI workloads. Why should you choose it? Earlier vector search tools were merely libraries, meaning you had to manage your text documents in one database and your vectors in another. ChromaDB solves this by handling the raw text, the embeddings, and the metadata all in one unified place. It offers full CRUD capabilities: create, read, update, and delete, making it perfect for datasets that change over time. When should you use it? It is fantastic for rapid prototyping using its simple in-memory client, but it also seamlessly transitions to robust production deployments using its HTTP client-server mode. This architecture diagram visualizes how ChromaDB simplifies your data layer. Raw text and documents are ingested through the ChromaDB client. Instead of splitting your data across multiple systems, everything is routed into a Chroma collection. Inside this single collection node, Chroma intelligently stores the mathematical embeddings, the descriptive metadata, and the raw text data side by side. This unified approach eliminates the headache of synchronizing separate databases and allows developers to focus purely on building their AI logic. Let's dive into how we integrate ChromaDB with actual code. First, you initialize a client. For testing, ChromaDB client creates an in-memory database, or you can use a persistent client to save data to disk. Next, you create a collection, which acts as a bucket for your specific project's documents. You can manually feed it text chunks, metadata, and IDs, and Chroma will automatically compute and store the embeddings. But it gets even easier with LangChain. You simply call chroma.fromDocuments, pass in your text splits, and an embedding model like OpenAI's, and your vector database is instantly provisioned. To retrieve data, calling similarity search on the database returns the exact text chunks that answer your prompt. Follow the sequence diagram to understand the code execution flow. The application makes a single call to LangChain's Chroma module using fromDocuments. LangChain automatically handles the heavy lifting, instructing the vector database to compute and store the embeddings. Later, when the user asks a question, the application triggers a similarity search. LangChain coordinates with the database to perform a rapid nearest neighbor search, ultimately returning the top K most relevant text chunks back to the application for processing. Now, let's shift our focus to FAISS. What is it? FAISS stands for Facebook AI Similarity Search, developed by Meta. It is crucial to understand the basics. Unlike Chroma, FAISS is a vector library, not a full database. This means it uses immutable data structures to store only the embeddings in memory, and you must maintain the actual raw text in a separate data store. Why would you choose it? For sheer, uncompromising speed and scale. FAISS is engineered for high-performance similarity search and clustering of dense vectors, supporting both CPU and GPU acceleration. You use FAISS when you are operating at an enterprise scale, dealing with millions or billions of vectors, and need sub-millisecond retrieval times. This flowchart highlights the performance-driven nature of FAISS. You can feed millions of embeddings into the FAISS library. Depending on your hardware, it leverages either CPU acceleration or highly optimized GPU acceleration. Both paths lead to lightning-fast indexing. The ultimate outcome at the bottom is sub-millisecond search capabilities. It strips away the overhead of managing text and metadata to focus 100% on mathematical efficiency and speed. Let's dive into how FAISS achieves this performance through its indexing algorithms. The most basic method is exact search, written as FAISS.indexFlatL2. This calculates the distance against every single vector, ensuring perfect recall, but it becomes a bottleneck at scale. To solve this, FAISS uses approximate nearest neighbor, or ANN, techniques. A standout algorithm is HNSW, Hierarchical Navigable Small World, which builds a multi-layered graph to achieve logarithmic search times, making it blistering fast with negligible accuracy loss. In practice, you can initialize an HNSW index using FAISS.indexHNSWFlat dimension 32. If you are using LangChain, it abstracts this complexity nicely. Simply use FAISS.from documents, embeddings to build your optimized index instantly. This diagram acts as a decision tree for FAISS indexing. It starts with index selection based on dataset size. If your dataset is small, you branch left to index flat L2, which provides exact search resulting in 100% accuracy, but slower speeds as data grows. If your dataset is large, you branch right to index HNSW flat. This utilizes approximate nearest neighbor search to deliver high accuracy combined with extreme speed. The right path is highlighted because it is the industry standard for production scaling. Let's solidify this with a real-time, high-value use case, building an enterprise RAG chatbot. The problem businesses face is that out-of-the-box LLMs hallucinate when asked about proprietary data because they weren't trained on internal company documents. The solution is the retrieval-augmented generation architecture. During the ingestion phase, we take internal HR policies or technical PDFs, chunk them into smaller pieces, convert them to embeddings, and store them securely in ChromaDB or FAISS. When an employee queries, "What is the new remote work policy?" the system doesn't guess. It converts the query to a vector, performs a semantic search in the vector store, retrieves the exact relevant paragraph, and the LLM synthesizes a factually grounded answer. Here is the visual flow of our enterprise chatbot in action. An employee question triggers the process. The text is converted into a vector embedding, which is then sent to our vector store, either FAISS or ChromaDB. The database executes a rapid semantic search and outputs the top K document chunks. These factual chunks are injected into the prompt for LLM synthesis, which finally yields a grounded, accurate answer on the far right. No hallucinations, just data-driven results. To conclude our deep dive, how do you choose? If you need a fully featured database that seamlessly handles raw documents, metadata filtering, and embeddings with full CRUD capabilities, ChromaDB is your best bet. If you are building a massive scale application requiring billion vector searches, and you need raw algorithmic speed and GPU optimization, FAISS is your high-performance engine. Looking ahead, the future of these stores lies in hybrid search, combining the dense vector semantics we discussed today with sparse, exact keyword matching for the ultimate accuracy. Mastering vector stores bridges the gap between static AI models and your dynamic, real-world data. Thank you for joining this session. Be sure to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram brings it all together. Your vector store strategy splits into two main paths based on your needs. The ChromaDB path offers a developer-friendly and unified experience. The FAISS path delivers maximum speed and scale. Regardless of which path you choose for your architecture, both ultimately lead to mastering the technology. And the best place to achieve that mastery and advance your career is through the comprehensive resources at quicktechie.com.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now, the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology-wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.